Okay, I just wanted to give a quick walkthrough on the LOL diagrams with the phase changes. So the example problem I gave was solid water at negative 10 degrees Celsius was heated until it was a liquid at 0 degrees Celsius. So if we were looking at a phase change diagram or a heating curve, down here it might be at negative 10. It heats up for a while. When it gets to 0, it starts going through a phase change, and then we are getting it all the way melted. So we were talking about going from one spot to the other. Our LOL diagram, we're going to have to do a separate one for each part of the curve. So starting off, negative 10, we have a very low thermal energy, maybe 2 blocks. Again, our max that we're going to say is probably like 10. And we are putting energy into it. Again, it could be any random amount, but not a ton of energy. So again, let's say maybe 2, which gets us to a total of 4 blocks of thermal energy. This drawing is representative of that point, and this drawing is representative of that point. Now we can continue on because we need to talk about this. So we're going to need another. Oh, energy is still going in. I'm going to say that 3 blocks of energy is going in, because maybe my plateau is longer than my slope. Regardless, what I do know for sure is that the temperature didn't change. So my thermal energy is going to stay constant at that 4 block level. But where did that energy go? That energy was required to make it change phases. So we have a new type of energy called phase energy. And that phase energy was always present. What we're going to say is that we're going to say solids have a phase energy of 1 block. So starting off over here, it was a solid. Starting off, or after warming it up, it was still a solid. And it still had 1 block. So our story is getting a little more complicated, but it should still make sense here. We get a different color. Starting off, solid water, it has a temperature, it has a phase. That 1 block is really just saying it is a solid. Then we added some energy right here, and now we increased the temperature to 4. Now that we've heated it up to the melting point, when we add more energy here, that energy is changing it from being a solid and going in and making it be a liquid. So the total number of blocks is still getting kind of conserved here. We have 1, 2, 3, and then 2 more right there. Give us a total of, 5 here, and 3 more. Give us a total of 8. We are just coming up with a way to show that the energy was changing the whole entire time. The temperature changed, but also the amount of energy necessary to get those particles to spread out was changing as well. So please do the other 2 problems on the homework assignment based off of that.